उसके बाद प्लांट ग्रोथ एंड डेवलपमेंट का एनसीईआरटी। तो एनसीईआरटी कहता है कि you have already studied the organization of the flowering plants in the chapter 5. Have you ever thought about where and how the structure like the roots of stem, leaf, flower, fruits and the seed arise, and that too in the ordinary sequence? You are by now aware of the term seed, seedlings, plantlet, mature plant. You have also seen that trees continue to increase in the height or the girth over a period of the time. However, the leaves, flowers, and the fruits of the same tree not only have the limited dimensions but also appear and fall periodically and sometimes repeatedly. Why does vegetative phase precede flowering in a plant? All the plant organs are made up of the variety of the tissue. Is there any relationship between the structure of a cell, tissue, organ and the function they perform? Can the structure and the function of these be altered? Are cells of a plant are descendants of the zygote? The question is then why and how do they have the different structural and the functional attributes? Development is the sum of the two processes, growth and their differentiation. To begin with, it is essential and sufficient to know that development of a mature plant from a zygote fertilized egg follow a precise and the highly ordered succession of the events. During this process, a complex body organization is formed that produces the root, leaves, branches, flower, fruits, and the seeds, and eventually they die. The first step in the process of the plant growth is the seed germination. The seed germinate when favorable conditions for the growth exist in the environment. In the absence of the such favorable conditions, the seed do not germinate and goes into a period of the suspended growth or the arrest. Once favorable conditions return, the seeds resume metabolic activity and growth take place. फिर कहता है कि इन दिस चैप्टर स्टडी सम ऑफ द फैक्टर्स विच गवर्न एंड कंट्रोल देयर डेवलपमेंटल प्रोसेस. these factors are both intrinsic internal and extrinsic internal to the plant. फिर आता है ग्रोथ. तो ग्रोथ के बारे में लिखता है कि ग्रोथ इज रिगार्डेड एज वन ऑफ द मोस्ट फंडामेंटल एंड द कॉन्स्पिक्यूअस कैरेक्टरिस्टिक ऑफ ए लिविंग बीइंग. व्हाट इज ग्रोथ? ग्रोथ कैन बी डिफाइंड as an irreversible permanent increase in the size of an organ or its part or even of an individual cell. Generally, growth is accompanied by the metabolic process, both anabolic and the catabolic, that occur at the expense of the energy. Therefore, for example, expansion of a leaf is a growth. How would you describe the swelling of the piece of the wood when placed in the water? तो ये दिया हुआ है. इधर जर्मिनेशन, इधर ये दिया हुआ है इधर ये दिया हुआ है जर्मिनेशन एंड द फील्डिंग डेवलपमेंट ऑफ ए बीन दिया हुआ है. तो इधर है फॉल है, इधर कोटिलीडॉन है, या हाइपोकोटॉल हो गया, फीड कोट हो गया, इपिकोटाइल हुक हो गया, कोटिलीडॉन्स हो गया, इपिकोटाइल हो गया और इधर हाइपोकोटॉल हो गया. फिर ये कहता है कि प्लांट ग्रोथ इज इनडिटर्मिनेट. कहता है कि plant growth is unique because plants retain the capacity for the unlimited growth throughout their life. This ability of the plant is due to the presence of the meristem at the certain locations in the body. The cells of such meristem have the capacity to divide and self-perpetuate. The product, however, soon loses the capacity to divide and such cells make up the plant body. This form of the growth where new cells are always being added to the plant body by the activity of the meristem is called as the open form of the growth. What would happen if the meristem fails to divide? Did this ever happen? In the chapter 6, we have studied about the root apical meristem and the shoot apical meristem. We know that they are responsible for the primary growth of the plant and they principally contribute to the elongation of the plant along their axis. We also know that in the dicot plant and the gymnosperm, the lateral meristem, vascular cambium and the core cambium appear later in the life. These are the meristem that cause the increase in the growth of the organ in which they are active. This is known as the secondary growth of the plant. फिर आता है ग्रोथ इज मेजरेबल. Growth at the cellular level is principally a consequence of the increase in the amount of the protoplasm. Since increase in the protoplasm is difficult to measure directly, one generally measures some quantity which is more or less proportional to it. Growth is therefore measured by a variety of the parameters, some of which are increase in the fresh weight, dry weight, length, volume, and the cell number. You may find it amazing to know that one single maize root apical meristem can give rise to more than 17,000 pounds of new cells per hour, whereas cells in a watermelon may increase in size up to the 3,50,000 times. In the former, growth is expressed as the increase in the cell number, the latter expressed growth as the increase in the size of the cell. While the growth of the pollen tube is measured in the terms of its length, and increase in the surface field denotes the growth in the dorsiventral leaf. फिर आता है phases of the growth. The period of the growth is generally divided into three phases, namely the meristematic, elongation, and the maturation. Let us understand this by looking at the root tips. The constantly dividing cells, both at the root apex and the foot apex, represent the meristematic phase of the growth. The cells in the region are rich in the protoplasm, possess large conspicuous nuclei. Their cell walls are primary in the nature, thin and physiologic with the abundant plasmodesmatal connection. The cells proximal just next away from the tip to the meristematic zone represent the phase of the elongation. Increased vacuolation, cell enlargement, and new cells multiplication are the characteristics of the cell in this phase. Further away from the apex, that means more proximal to the phase of the elongation, lie the cortex, lie the portion of axis which is undergoing the phase of the maturation. The cells of this zone attain their maximal size in the terms of the wall thickening and the protoplasmic modifications. Most of the tissue and the cell type we have studied in chapter 6 represents this phase. फिर आता है ग्रोथ रेट. तो the increased growth per unit time is determined as the growth rate. The rate of the growth can be expressed mathematically. An organism or a part of the organism can produce more cells in a variety of the बेज. तो ये दिया हुआ है यहाँ पर अरिथमेटिक, ये जियोमेट्रिक दिया हुआ है, ये है जागोट डिवाइड किया, जियोमेट्रिक फेज सेल डिवाइड किया. उसके बाद फिर आता है ये हो गया अरिथमेटिक फेज हो गया. Whether there were cells capable of the division, ये दिखाया cells that lose the capacity to the divide. फिर यहाँ पर दिया हुआ डायग्रामेटिक, फिर यहाँ पर दिया हुआ है diagrammatic representation of the arithmetic, geometric and the stage during the embryo development showing the geometric and the arithmetic phases. फिर यहाँ पर ये दिया हुआ है diagrammatic representation of the location of the root apical meristem, foot apical meristem and the vascular cambium. Arrow exhibit the direction of the growth of the cells and the organ. ये हो गया रूट, ये हो गया फुट, ये हो गया vascular cambium, ये हो गया फुट apical meristem, ये हो गया vascular cambium और ये हो गया रूट apical meristem. फिर आता है यहाँ पर दिया हुआ है डिटेक्शन ऑफ द जोन्स ऑफ द इलोंगेशन बाय द पैरेलल लाइन टेक्निक. जोन्स ए बी सी डी रिप्रेजेंट द बिहाइंड द एपेक्स ऑफ द इलोंगेटेड मोफ्ट. उसके बाद फिर आता है इनफैटिफिक आता है कि द growth rate for an increase that may be arithmetic or the geometrical. In the arithmetic growth following mitotic cell division, only one daughter cell continue to divide while the other differentiate and mature. The simplest expression of the arithmetic growth is amplified by the root elongating at a constant rate. Look at the figure 15.1 on plotting the length of the organ against the time. A linear curve is obtained mathematically expressed as LT is equal to L नॉट प्लस आर टी. यहाँ एल टी है जो लेंथ ऑफ एट द टाइम टी है, एल नॉट लेंथ एट द टाइम जीरो है और आर जो है ग्रोथ रेट है, एलोंगेशन पर यूनिट टाइम है. फिर कहता है कि लेट अस नाउ सी व्हाट हैपेंस इन द ज्योमेट्रिकल ग्रोथ. इन मोस्ट सिस्टम द इनिशियल ग्रोथ इज स्लो लैग फेज एंड इट इंक्रीजेस रैपिडली देयर आफ्टर at an exponential rate log or the exponential phase. Here both the progeny cells following mitotic cell division retain the ability to divide and continue to do so. However, with the limited nutrient supply, the growth phase slowed down leading to a stationary phase. If we plot the parameter of the growth against time, we get a typical sigmoid or if the S curve. A sigmoid curve is a characteristic of the living organism growing in a natural environment. It is typical for all the cells, tissue and the organs of a plant. Can you think of more similar example? What kind of curve can you expect in a tree showing the seasonal activity? The exponential growth can be expressed as W1 is equal to W0 ERT, where W1 is the final size, B8 is number, etc. W0 is the initial size at the beginning of the period, R is the growth rate, T is the time of the growth, or E is the base of the natural logarithm. Here I the relative growth and also the measure the ability of the plant to produce the new plant material referred to as the efficiency index. Hence the final size W1 depends on the initial size W0. फिर यहाँ पर दिया हुआ कॉन्स्टेंट लीनियर ग्रोथ ए प्लॉट ऑफ द लेंथ अगेंस्ट द टाइम टी. यहाँ पर दिया हुआ इधर हाइट ऑफ द प्लांट. फिर यहाँ पर दिया हुआ इधर साइज या वेट ऑफ द ऑर्गन. इधर दिया हुआ एन एटलाइड सिग्मोइड ग्रोथ टिपिकल ऑफ सेल इन द कल्चर एंड मैनी हायर प्लांट्स एंड प्लांट ऑर्गन्स. ये लैग फेज हो गया, ये एक्सपोनेंशियल फेज हो गया, ये एक्सपोनेंशियल फेज हो गया और इधर ये हो गया स्टेशनरी फेज हो गया और यहाँ पर ये टाइम शो किए हुए. फिर आता है diagrammatic comparison of the absolute and the relative growth rate. Both leaves A and the B have increased their area by the 5 cm square in a given time to produce the A dash and the B dash leaves. फिर आता है qualitative comparison, quantitative comparison between the growth of the living system can also be made into two ways. पहला measurement and the computation of the total growth per unit time is called as the absolute growth rate. The growth of the given system per unit time expressed as a common basis per unit initial parameter is called as the relative growth rate. In the figure 15.7, two leaves A and B are drawn that are of different sizes but show absolute increase in the area in the given time to give the leaves A dash and the B dash. However, one of them shows the much higher relative growth rate, which one and why. तो ये है और ये बी है. 5 से 10 हो गया, ये 50 से 55 हो गया. फिर आता है कंडीशन फॉर दी ग्रोथ. तो why do you not try to write down what do you think are necessary condition for the growth? The lift may have water, oxygen, nutrients as very essential elements for the growth. The plant shall grow in the size by the cell environment which in turn requires the water. The aridity of the cell helps in extension of the growth. Thus the plant growth and further development is intimately linked to the water status of the plant. Water also provides the medium for the enzymatic activity needed for the growth. Oxygen helps in increasing the metabolic energy essential for the growth activity. Nutrients, macro and the macro essential elements are required by the plant for the synthesis of the protoplasm and act as a source of the energy. In addition, every plant organism has an optimum temperature range best suited for its growth. Any deviation from the range could be detrimental to the survival. Environmental signals such as light and the gravity also affect certain phases or stage of the growth. फिर आता है डिफरेंशिएशन, रीडिफरेंशिएशन एंड डी-डिफरेंशिएशन. द सेल्स कहता है कि द सेल्स derived from the root apical and the foot apical meristem and cambium differentiate and mature to perform the specific function. This act lead to the maturation intermediate differentiation. During the differentiation, cell undergo few to major structural changes both in the cell walls and protoplasm. For example, to form a tertiary element, the cells could lose their protoplasm. They also develop a very strong elastic lignocellulosic secondary cell walls to carry water to the long distance even under the extreme tension. Try to correlate the various anatomical features you encounter in a plant to the function they perform. फिर कहता है कि plants for another interesting phenomena, the living differentiated cell that by now have lost the capacity to divide and regain the capacity of the division under the certain condition. This phenomena is termed as the de-differentiation. For example, formation of the meristem, interfascicular cambium and the core cambium from the fully differentiated parenchyma cells. By doing so, such meristem tissues are able to divide and produce cells that once again lose the capacity to divide but mature to perform a specific functions, that means get re-differentiated. List some of the tissue in a woody dicotyledonous plant that are product of the re-differentiation. How would you describe a tumor? What would you call the parenchyma cells that are made to divide and the controlled laboratory condition during the plant tissue culture? फिर आता है recall in the section 15.1.1 we have mentioned that the growth in the plant is open, that means it can be indeterminate or determinate. Now we must say that even differentiation in the plant is open because cells tissue arising off the same meristem have different structure at the maturity. The final structure at the maturity of a cell tissue is also determined by the location of the cell within. For example, cell positioned away from the root apical meristem differentiate as the root cap cells while those pushed up to the periphery mature as the epidermis. Can you add a few more examples of the open differentiation correlating the position of the cell to its position in an organ? फिर आता है डेवलपमेंट. तो development is a term that includes all the changes that an organism goes through its life cycle from the germination of the seed to the senescence. Diagrammatic representation of the sequence of the process which constitute the development of the cell of the higher plant given in the figure 15.8. It is also applicable to the tissue या organs के लिए. तो यहाँ पर दिया हुआ है, ये दिया हुआ सीक्वेंस ऑफ द डेवलपमेंटल प्रोसेस इन द प्लांट सेल्स में. तो ये हो गया मेरिस्टेमेटिक सेल्स, प्लाज्मेटिक ग्रोथ किया, डिफरेंशिएशन किया, तो उसके बाद प्लाज्मेटिक ग्रोथ मतलब सेक्शन एलोंगेशन किया, मैचुरेशन किया, मैच्योर सेल बना, फिर सेनेसेंस हुआ, डेथ हुआ, और यहाँ पर प्लाज्मेटिक ग्रोथ मतलब सेल डिवीजन हुआ और मेरिस्टेमेटिक सेल हो रहा है. फिर आता है कि plant for different pathway in the response to the environment or the phases of the life to perform different kinds of the structure. This ability is called the plasticity. Example, heterophyly in the cotton, coriander and the larkspur. In such plants, the leaves of the juvenile plant are different in the shape and form those in the mature plant. On the other hand, difference in the shape of the leaves produced in the air and those produced in the buttercup also represent the heterophilous development due to the environment. This phenomenon of the heterophyly example of the plasticity. फिर आता है ये जुवेनाइल हो गया, ये एडल्ट हो गया. इसका टेरेस्ट्रियल हैबिटाट है और इसका है जो वाटर हैबिटाट है. तो वाटर हैबिटाट में बिल्कुल अलग है. तो हेटेरोफिल ये लार्क्सपर में और ये बटरकप में. तो लार्क्सपर में जो होता है ये होता है लार्क्सपर में होता है वो होता है डेवलपमेंटल, और जो बटरकप में होता है वो होता है इन्वायरमेंटल. Thus, the growth, differentiation, and development are very closely related events in the life of a plant. Broadly, development is considered as the sum of the growth and the differentiation. Development in the plants, that means both growth and the differentiation, is under the control of the intrinsic and extrinsic factors. The former includes both intercellular genetic or the intercellular factors, chemicals such as the plant growth regulators, while the latter includes the light, temperature, water, oxygen, nutrition, etc. फिर आता है plant growth regulators characteristic. The plant growth regulators are a small simple molecules of the diverse chemical composition. They could be indole compounds, indole 3 acetic acid IAA, adenine derivatives N6-perfluoroaminopurine kinetin, derivatives of the carotenoids abscisic acid ABA and the terpenes gibberellic acid GA3 or the gaseous ethylene C2H4. Plant growth regulators are variously described as the plant growth substance, plant hormones, or the phytohormones in the literature. The PGR can be broadly divided into two groups based on their functioning in the living plant body. One group of the PGR involved in the growth promoting activities such as the cell division, cell alignment, pattern formation, topic growth, flowering, fruiting, and the seed formation. These are also called as the plant growth promoters. Example: oxygen, gibberellins, and the phytokinins. The PGR of the other group plant play an important role in the plant response to the wound and the stress of the biotic and the abiotic origin. They are also involved in the various growth inhibiting activities such as the dormancy and the abscission. The PGR abscisic acid belong to this group. The gaseous PGR ethylene could fit either of the group, but it is largely in the inhibitor of the growth activities. फिर आता है the discovery of the plant growth regulators. Interestingly, the discovery of each of the five major groups of the PGR have been accidental. All this started with the observation of the Charles Darwin and his son Francis Darwin when they observed that the coleoptiles of the canary grass responded to the unilateral illumination by the growing towards light source photoperiodium. After a study of the experiment, it was concluded that the tip of the coleoptile by the fact of the transmittable influence that causes the bending of the entire coleoptile. Oxygen was oscillated by the FW bend from the tip of the coleoptiles of the oat seedling से. तो इसमें दिखाया गया कि experiment used to demonstrate that tip of the coleoptile is the source of the oxygen. Arrows indicate the direction of the light दिखा रहा है. फिर एक आता है the backend fully fielding disease of the rice fielding was caused by the fungal pathogen Gibberella fusariae. E. Kurosawa 1926 reported the appearance of the symptoms of the disease in the rice fielding when they were treated with the sterile filtrates of the fungus. The active substance were later identified as the gibberellic acid. F. S. Cook and his co-workers observed that from the internodal segment of the tobacco stem, the callus, a mass of the undifferentiated cells, proliferated only if, in addition to the oxygen, the nutrient medium was supplemented with one of the following: extracts of the vascular tissue, if to extract coconut milk or the DNA. Miller et al. 1955 में later identified and crystallized the phytokinesis promoting active substance that determined the kinetin. फिर आता है during the mid 1960s, three independent researchers reported the purification and the chemical characterization of the three different kinds of the inhibitor B, abscission 2, and the dormin. Later, all the three were proved to be chemically identical. It was named the abscisic acid. H.H. Cousins confirmed the release of the volatile substance from the ripened oranges that had hastened the ripening of the stored unripened bananas. Later, this volatile substance was identified as the ethylene and gaseous PGR. Let us study some of the physiological effects of these five categories of the PGR in the next section. फिर आता है physiological effect of the plant growth regulators, auxins. The auxins from the Greek word auxin to grow by first isolated from the human urine. The term auxin is applied to the indole 3 acetic acid and to the other natural and the synthetic compound having certain growth regulator properties. They are generally produced by growing apices of the stem and the root from where they migrate to the region of their action. Auxins like the IAA and the indole butyric acid have been isolated from the plant. Na-naphthalene acetic acid and the 2,4-D and the 2,4-dichlorophenoxyacetic acid and other synthetic organs. All the organs have been used extensively in the agriculture and the horticulture practices. They help to initiate rooting in the stem cutting and application widely used for the plant propagation. Auxins promote the flowering, that means example in the pineapples. They help to prevent the fruit and the leaf drop at the early stage but promote the absorption of the older mature leaves and the fruit. फिर कहता है कि in the most higher plants, the growing apical buds inhibits the growth of the lateral axillary buds, a phenomenon called as the apical dominance. Removal of the foot tip decapitation usually results in the growth of the lateral buds. It is widely applied in the tea plantation hedge making. Can you explain why? फिर आता है कि auxins also induce the parthenocarpy. Example in the tomato, they are widely used as the herbicide 2,4-D, widely used to kill the dicotyledonous weeds, does not affect mature monocotyledonous plant. It is used to prepare weed-free lawns by the gardeners. Auxins also control the xylem differentiation and helps in the cell division. फिर इसमें आता है जिबर्लिन्स. तो जिबर्लिन्स के बारे में कहता है Gibberellins are another kind of the Pormatry PGR. There are more than 100 gibberellins reported from the badly different organisms such as the fungi and the higher plants. They are denoted as a GA1, GA2, GA3 and so on. However, gibberellic acid 3 was one of the first gibberellins to be discovered and remains the most intensive studied form. All the gibberellic acid are acidic. They produce a wide range of the physiological response in the plant. Their ability to increase the in the length of the axis used to increase the length of the grapes stalk. Gibberellins cause the fruit like the apples to elongate and improve its shape. They also delay the senescence of the fruit can be left on the tree longer for it to extend the market period. GA3 used to speed up the malting process in the brewing industry. Sugarcane stores the carbohydrate as the sugar in the stem. A spraying sugarcane crop with the gibberellins increase the length of the stem, thus increasing the yield by as much as by the 20 tons per acre. फिर आता है कि spraying the juvenile conifers with the GA hasten the maturity period, thus leading to the early seed production. Gibberellins also promote the bolting internode elongation just prior to the flowering in the beet, cabbage and many plants with the rosette habit. तो ये दिया हुआ है apical dominance in the plant, a plant with the apical bud intact, a plant with the apical bud removed, not the growth of the lateral bud into the branches after the decapitation. फिर दिया आता है phytokinins. So phytokinins have the specific effects on the phytokinesis and were discovered as the kinetin, a modified form of the adenine a purine from the autoclaved herring of sperm DNA. Kinetin does not occur naturally in the plant. Search for the natural substances with the kinetin lack the activities led to the evolution of the gelatin from the corn kernels and the coconut milk. Since the discovery of the gelatin, several naturally occurring cytokinins and some synthetic compounds with the cell division promoting activity have been identified. Natural cytokinins are synthesized in the regions which where rapid cell division occur. For example, root appendages, developing fruit buds, young fruits, etc. It helps to produce the new leaves, chloroplast in the leaves, lateral foot growth, and the adventitious foot formation. Cytokinins help overcome the apical dominance. They promote the nutrient proliferation, which helps the delay of the leaf senescence. फिर आता है ethylene. तो ethylene is a simple gaseous PGR. It is synthesized in the large amounts by the tissue undergoing the senescence and ripening fruit. Influence of the ethylene on the plants include the horizontal growth of the seedlings, swelling of the axis and the apical hook formation in a dicot filling. Ethylene promotes the senescence and absorption of the plant organs, especially in the leaves and the flower. Ethylene is highly effective in the fruit ripening. It enhances the respiration rate during the ripening of the fruit. This rise in the rate of the respiration is called as the respiratory climacteric. Ethylene breaks seed and the bud dormancy initiates germination in the peanut seeds of sprouting of the potato tubers. Ethylene promotes the rapid internode petiole elongation in a deep party rice plant. It helps leaves and upper part of the foot to remain above water. Ethylene also promotes the root growth and the root hair formation, thus helping the plant to increase their absorption surface. फिर आता है कि ethylene is used to initiate the flowering and for synchronizing fruit set in the pineapples. It also induces the flowering in the mango. Since ethylene regulates so many physiological processes, it is one of the most widely used PGR in the agriculture. The most widely used compound as the source of the ethylene is the ethifone. Ethifone is an aqueous solution in readily absorbed and transported with the plants and release ethylene slowly. Ethifone happens the fruit ripening in a tomato and the apple and affiliates the absorption in the flowers and the fruits, thinning of the cotton, cherry and the walnut. It promotes the female flower in the cucumber and thereby increasing the yield. फिर आता है abscisic acid. As mentioned earlier, the abscisic acid ABA was discovered for its role in the regulating abscission and dormancy, but like the other PGR, it also has other wide-ranging effect on the plant growth and the development. It acts on a general plant growth inhibitor and inhibitor of the plant metabolism. ABA inhibits the seed germination. ABA stimulates the color of the stomata and increase the tolerance of the plant to various kind of the stresses. Therefore, it is also called as the stress hormone. ABA play an important role in the seed development, maturation, and the dormancy. By noticing the dormancy, ABA helps feed to better stand desiccation and other factors unfavorable for the growth. In most situations, ABA acts as an antagonist to the gibberellic acid. We must summarize that for any and every phase of the growth, differentiation and development of the plant, one or the other PGR has some role to play. Such roles could be complementary or the antagonistic. These could be individualistic or synergistic भी हो सकते हैं. फिर आता है कि similarly there are a number of the events in the life of a plant where the more than one PGR interact to the affect that event. To mention the seeds, bud, abscission, senescence, and apical dominance, etc. Remember the role of the PGR is one kind of the intensive control along with the genomic control and intrinsic factor. They play an important role in the plant growth and development. Many of the extrinsic factors such as the temperature and the light control plant growth and development via the PGR. Some of the such events could be vernalization, flowering, dormancy, seed germination, plant movement, etc. Before discuss briefly the role of the light and the temperature, both of them the extensive factor on inserting of the flowering. फिर आता है पहला टॉपिक इसमें आता है फोटोपीरियोडिज्म. तो इट हैज़ बीन ऑब्जर्व्ड दैट सम प्लांट्स रिक्वायर periodic exposure to the light to induce the flowering. It is also seen that such plants are able to measure the duration of the exposure of the light. For example, some plants require the exposure of light for a period exceeding a well-defined critical duration, while others must be exposed to light for a period less than this critical duration before the flowering is inserted in them. The former group of the plant are called as long day plant, while the latter ones are termed as the short day plant. The critical duration is different for the different plants. There are many plants, however, where there is no such correlation between exposure to the light duration and the induction of the flowering response. Such plants are called as a day neutral plant. It is now also uh, known that not only the duration of the light period but that the duration of the dark period is also of the equal importance. Hence, it can be said that flowering in the certain plant depends not only on the combination of the light and the dark exposure but also their relative duration. This response of the plant to periods of the day-night is termed as the photoperiodism. It is also interesting to note that while the fruit apices modify themselves into the flowering apices prior to the flowering, that means the fruit apices of the plant by themselves cannot perceive the photoperiod. The fact of the perception of the light to the dark duration are the leaves. It has been hypothesized that there is a hormonal substance that is responsible for the flowering. This hormonal substance migrates from the leaves to the fruit apices for the inducing flowering only when the plants are exposed to the necessary inductive photoperiod. तो ये दिया हुआ है फोटोपोडियम लॉन्ग डे शॉर्ट डे एंड डे न्यूट्रल प्लांट का. तो ये हो गया लॉन्ग डे प्लांट, ये हो गया शॉर्ट डे प्लांट. फिर उसके बाद आता है डे न्यूट्रल प्लांट. इसका फ्लावरिंग दिए हुए एवब में फिर आता है क्रिटिकल डे फोटो पीरियड और फिर नो फ्लावरिंग क्रिटिकल फोटो पीरियड बिलो. फिर उसके बाद यह है नो फ्लावरिंग, फ्लावरिंग कर गया. अब फ्लावरिंग आफ्टर द वेजिटेटिव मैच्योरिटी हो गया. फिर उसके बाद आता है वर्नलाइजेशन. तो Ncert कहता है कि these are the plants for which the flowering either qualitatively or the quantitatively dependent on the exposure to the low temperature. This phenomenon termed as the vernalization. It prevents the precocious reproductive development late in the growing season and enables the plant to have sufficient time to reach maturity. Vernalization refers especially to the promotion of the flowering by a period of a low temperature. Some important food plant, wheat, barley, rye, have two kinds of the variety, winter and the spring varieties. The spring variety are normally planted in the spring and come to the flower and produce grain before the end of the growing season. Winter variety, however, if planted in the spring, would normally fail to flower or produce mature grain within a span of the flowering season. Hence, they are planted in the autumn, they germinate and over winter come out as a small seedlings, resume growth in the spring and are harvested usually around the midsummer. Another example of the vernalization is seen in the biennial plants. Biennials are the monocarpic plants that normally flower and die in the second season. Sugar beet, cabbage, carrot are some of the common biennials. Subjecting the growing of the biennial plant to the cold treatment stimulates the subsequent photoperiodic flowering response. फिर आता है seed dormancy. So there are certain seeds which fail to germinate even when the external conditions are favorable. Such seeds are understood to be undergoing a period of dormancy which is controlled not by the external environment but are under the endogenous control or condition within the seed itself. Impermeable and hard seed core presence of the chemical emitters such as the abscisic acid, phenolic acid, pyroascorbic acid, and the immature uh, emerge are some of the regions which could cause the seed dormancy. This dormancy, however, can be overcome through the natural means and the various other man-made measures. For example, the seed coat barrier in the some seed can be broken by the mechanical abrasion using knife, sandpaper, etc., or the Viagra shaking. In nature, these abrasions are caused by the microbial action and passage through the digestive tract of the animals. Effect of this innovative substance can be removed by subjecting the seeds to the chilling condition or by the application of the certain chemicals like the gibberellic acid and the nitrates. Changing the environmental conditions such as light and the temperature and the other methods to overcome the seed dormancy. फिर summary इसका है कि growth is one of the most conspicuous events in any living organism. It is an irreversible increase expressed in the parameters such as the area, length, size, height, volume, cell number, etc. It conversely involves increased photoplasmic material in the plants. Meristem are the facts of the growth, roots, and the fruit apical meristem, sometimes along with the intercalary meristem, contribute to the elongation Growth of the plant as such. Growth is indeterminate in the higher plants following cell division in the root and the foot apical meristem cells. The growth could be arithmetic or the geometrical. Growth may not be and generally is not sustained at a higher rate throughout the life of the cell, tissue, organism, etc. One can define three principal phases of the growth: the lag, the log, and the senescence phase. When a cell loses the capacity to divide, it leads to the differentiation. Differentiation results in the development of the structure that is commensurate with the function of the cell finally had to perform. General principle of the differentiation for the cell, tissue, and organs are similar. A differentiated cell may de-differentiate and then re-differentiate. Since differentiation in the plant is open, the development could also be flexible. That means development is the sum of the growth and the differentiation. Plant exhibit the plasticity in the development. फिर कहता है कि plant growth and development are under the control of the both intrinsic and extrinsic factor. Intercellular intrinsic factors are the chemical substances called plant growth regulators. They are diverse group of the PGR in the plant, principally belonging to the five group: auxin, gibberellin, cytokinin, sulfuric, and the ethylene. These PGR are synthesized in the various part of the plant. They control the different differentiation. They control the different differentiation and developmental events. Any PGR has diverse physiological effect on the plant. Diverse PGR also manifest similar effect. PGR may act synergistically or antagonistically. Plant growth and development is also affected by the light, temperature, nutrition, oxygen status, gravity, and other such factors. Flowering in the some plants is indifferent only when exposed to the certain duration of the photoperiod, depending on the nature of the photoperiod requirement. The plants are called the short day plant, long day plant, and the day neutral plant. Certain plants also need to be exposed to low temperature exposure to hasten the flowering later in the life. This treatment is known as the vernalization.
तो आइए करीब आइए, कहीं ऐसा ना हो कि आप सोचते रह जाए और हमारी प्रचार गाड़ी फिर आगे बढ़ जाएगी तो बाद में आपको हाथ मलना पछताना पड़ेगा, क्योंकि भाई